Take two. So I'm gonna, my truth table is all here. I have A, is switch 1, B, switch 2, C, switch 3. And this is what we have. This blue wire, A, is going into this inverter, this knot, and it comes out with the blue spotted blue and white wire, and that goes into, then we have our AND chip. So we're using two of the ANDs. We have the A knot and B in one AND that comes out as orange. Then we have regular A that skipped the inverter, it goes straight to the AND, and C, brown, and they come out as yellow. Those two both go into the OR. The orange and the yellow go into OR. So if either one of orange or yellow has power, white gets power, and the railroad light goes on. And I'll demonstrate that according to my truth table. First line of my truth table says that if you have nothing, then you don't get any. If you have 0, none of the switches are on, A off, B off, C off, you don't have, that's the way it should be. What happens if you just turn on C? You still have nothing because the equation said A and C. C alone doesn't do it. What about, my next line is going to say just B. B will go on. Why does B go on? B fulfills A not B. A is not. B is on. Therefore, they go through it. It works out as explained before. The next line will be B and C. B and C, well, that's the same as we just did. We just did this. Now if you add the C, it doesn't change anything because the C, the second AND is still off, but the first one is still on. The next one, however, what happens if you just have A? A doesn't do anything. Shouldn't do anything because it's inverted to, first of all, B's off, and it's inverted to 0. Okay. Next line, what about A and C? A and C needs to work because that's part of the equation. Either A not B or A and C. So A and C. Boom. That's going to the second AND, brown, and the blue from behind is the regular A, comes out yellow, boom. And finally, that was A and C. A and B, I think I just showed that. A and B, I guess not. I just showed B. Just B I showed. Did I show that when you turn on A, it's off? No, I showed B and C. Just B and C, it still worked, but A will turning on A will shut off because now my B is together with a knotted A that's on, which turns into 0. So the 0 and the B don't work. And the final one, if I have all three, that also works because even though these two won't work, but now forget about these two, we will have A and C for the second fulfillment of OR, and that's why it goes on.